Welcome to BarnesBasics, and I wanted to do a word problem involving a decomposition reaction. When heated, potassium chlorate decomposes, yielding potassium chloride and oxygen. In this reaction, we can look at a periodic chart and find the symbol for K potassium, and since it is in group 1A, it has an oxidation number of +1. If we look on our polyatomic ion chart, then chlorate is ClO3 -1. And in a previous video, I did ask you to download an oxidation number polyatomic ion sheet and an oxidation number rule sheet. So if you haven't done that, if you don't have this in hand, go ahead and just stop the video and download those. There's also an instructional video that I have. It says something like BarnesBasics, balancing equations, do this first, or something like that. So watch that video. That one's a great video. Potassium chlorate decomposes. It basically means it's time to put a yield sign in this chemical reaction, and it yields potassium chloride. Again, we know that potassium has a +1 oxidation number. We know that chlorine has a -1 oxidation number, and it says that we also yield oxygen. So let's talk about all of these things. Chlorate is a polyatomic ion, so it stays together. The potassium is +1 and the chlorate's -1. So these balance. We're fine here. There's nothing more to do with that compound. Potassium and chlorine balance. That is neutral. So we're good to go there. There is a little thing to know with gases, and it could be anything from nitrogen gas to chlorine gas to bromine gas. All of these are neutral in their elemental state, and they're also diatomic. So there are some gases, as you can see, as is oxygen in this problem, that are diatomic in their natural state, and you just have to know that automatically, and you have to know to assign them an oxidation number of 0. In this formula, there's one potassium on the left, one on the right. And it's not going to be so simple because the chlorate has been split in this equation, and so we can't easily balance for a polyatomic here. There is a 3 here for oxygen and a 2 here, and I'm thinking you and I should be gunning for a least common multiple of 2 and 3, which would be 6. So why don't we do that and see what happens. Let's put a 3 in front of the elemental oxygen. We'll have 3 times 2 is 6. And then let's put a 2 in front of the potassium chlorate. 2 times 3 is 6. And now we have 2 potassiums and 2 chlorines. So it looks like an easy fix for this decomposition reaction is just to place a 2 in front of the potassium chloride. So we have 2 potassiums on the left, 2 on the right, 2 chlorines left, 2 right. 2 times 3 is 6. We have 6 oxygens on the left, and 3 times 2 is 6. And I would say that this looks pretty good.